So in this video I'll talk about nucleophilic substitution. Nucleophilic substitution reaction তখনই হয় যখন আমরা একটা halogenalkane হিট করছি. The halogenalkane has a compound that has a halogen atom in it. For example, this halogen atom can be chlorine, bromine or iodine. If this is chlorine, this is chloroethane. If this is bromine, this is bromoethane. If this is iodine, this is iodethane. So এরকম একটা কম্পাউন্ড যেটার মধ্যে হ্যালোজেন আছে, that is called a halogenalkane. আমরা যদি এরকম একটা halogenalkane hydroxide ion এর সাথে হিট করি, so for example if you are heating the halogenalkane with sodium hydroxide or potassium hydroxide, and if you are heating it under reflux, if you heat it under reflux, then hydroxide ion is able to substitute the halogenalkane and produce an alcohol. In nucleophilic substitution, the halogen atom of the halogenalkane gets substituted by a nucleophile, for example by a hydroxide, or it can be by another nucleophile, for example by cyanide. So this is the overall reaction of nucleophilic substitution. Now, nucleophilic substitution can occur by two ways. Nucleophilic substitution can occur by either Sn2 mechanism or by Sn1 mechanism. We will talk about this mechanism shortly. But before we start with that, we have to understand first the order of reaction. Now, you should know about collision theory from O levels. আমরা O levels এ collision theory পড়ে এসেছি। And collision theory আমাদেরকে কি বলে? Collision theory tells us যে the rate of reaction depends on the frequency of collision of particles. So আমরা for example যদি concentration increase করি, rate of reaction increase করে, এবং concentration increase করলে rate of reaction কেন increase করে? Because if you increase the concentration, the particles collide more frequently, and if the particles collide more frequently, they will produce more product. They will produce product at a faster rate. So if I increase the concentration of a reactant, the rate of reaction increases proportionately. And if this is the case, that is, if from experiment I find out that, for example, suppose I have a reaction in which A plus B reacts to produce C, and আমি এক্সপেরিমেন্ট করে দেখলাম যে আমি যদি এর কনসেন্ট্রেশন ইনক্রিজ করি, then the rate of production of C also increases. If I increase the concentration of A, if I double the concentration of A, the rate of production of C also doubles. If I triple the concentration of A, the rate of production of C also triples. এরকম যদি আমাদের একটা directly proportional relationship হয় between the concentration and the rate of reaction, then this reaction is said to be first order with respect to A. এই রিঅ্যাকশনটাকে আমরা বলবো first order with respect to A. আবারও, if the rate of a reaction increases proportionately with the increase in concentration of a substrate, increase in concentration of a reactant, then the reaction is said to be first order with respect to that specific reactant. Sometimes it may happen that আমরা concentration increase করছি, but rate of reaction increase করছে না। এটা কিভাবে হতে পারে? We will talk about it shortly, how this can happen. But sometimes it may happen that we are increasing the concentration of a reactant, but the rate of reaction does not increase. For example, আমি ধরো এই এক্সপেরিমেন্টে এই রিঅ্যাকশনে এক্সপেরিমেন্ট করে দেখলাম যে আমি বি এর কনসেন্ট্রেশন ইনক্রিজ করছি, but the rate of reaction does not increase. The rate of production of C remains the same. If by experimentation আমি দেখি যে concentration, increase in concentration of B does not have any effect on the rate of reaction, then this reaction is said to be zero order with respect to reactanter concentration increase করলে rate of reaction ও proportionately increase করে, then that reaction is said to be first order with respect to the reactant. আমি যদি কোনো একটা রিঅ্যাকশনে কোনো একটা রিঅ্যাক্টেন্টের কনসেন্ট্রেশন ইনক্রিজ করলে rate of reaction increase না করে, then that is said to be zero order with respect to the reactant. All right. Now, Sn2 mechanism occurs if we heat a tertiary halogenoalkane with hydroxide ions. For example, this compound 2-bromo-2-methylpropane, if I heat 2-bromo-2-methylpropane with sodium or potassium hydroxide under reflux, then it produces 2-methylpropane-2-ol. And here, as you can see, the hydroxide ion has replaced the bromide. The bromide has been kicked out, the bromide has been substituted, and it has been substituted by the hydroxide ion. This reaction occurs in 2 steps. In step 1, the carbon-bromine bond or the carbon halide bond undergoes a heterolytic bond fission to produce a carbocation and the halide ion, or in this case the bromide ion. Once again, this carbon-bromine bond is polar. This carbon-bromine bond is polar because bromine is more electronegative than carbon. Bromine is continuously trying to pull away with the electrons from the carbon. But the carbon normally does not let it go away with the electrons. Carbon কিন্তু ইলেকট্রনগুলোকে ধরে রেখেছে because carbon in this bond, in this carbon-bromine bond, carbon itself has one electron and another electron is from bromine. So carbon does not want to let go of its electrons under normal circumstances. But as this halogenoalkane is tertiary, this carbon, and that means the carbon is bonded to 3 other carbon atoms directly, and all these carbon atoms has a positive inductive effect. Positive inductive effect means they are electron donating. All this alkyl group donate electrons to the carbon, and if they donate electrons to the carbon, this positive charge becomes less than normal. Once again, in the carbon-bromine bond, bromine is electronegative and it is continuously trying to pull away with the electrons from the carbon-bromine bond. Normally, the carbon does not let it happen because the carbon itself has an attraction for the electrons of carbon itself and also of the electron of bromine. But in case of a tertiary halogenoalkane, as this carbon is bonded to 3 other carbon atoms and all these 3 other carbon atoms donate electron to this central carbon, the positive charge of the carbon gets reduced. And if the positive charge of the carbon gets reduced, then it is possible for the bromine to pull away with the electrons from the carbon-bromine bond and undergo heterolytic bond fission. Heterolytic bond fission means the bond breaks apart in such a way that bromine gets both the electrons and carbon gets none of the electrons. And as a result, it produces this carbocation. একটা carbocation produce করছে. What is a carbocation? A carbocation is an organic compound that has a carbon positive charge, as you can see over here. এখানে the carbon has a positive charge because the carbon has virtually lost an electron to the bromine. Bromine যে দুইটা ইলেকট্রন নিয়ে বের হয়ে গেছে, that is from the carbon-bromine bond. And so, whenever the bond undergoes heterolytic bond fission, then the carbon becomes a positive charge center. And this reaction, this first step is a very slow step. This occurs very slowly because carbon, although it is less positive, it is reluctant to let go of the bromine, and once they are produced, they can always reform back. They can always attract each other and react together to form the halogenoalkane. But sometimes, as we are heating this mixture with sodium hydroxide, sometimes it may happen that the carbocation that is produced gets immediately attacked by a nucleophile, for example, the hydroxide ion. এখানে আমরা কিন্তু রিঅ্যাকশনটা হচ্ছে we are heating the whole solution with the hydroxide ion. So hydroxide ion is always there, এবং আমরা যখন হিট করি, আমরা যখন এটাকে when we are heating it under reflux, then the hydroxide ion can actually attack this carbon immediately attack this positive charge immediately, and it produces a carbon hydroxide bond, which is very strong, and so this step is irreversible and this step is very fast, and thus it produces a tertiary alcohol. Once again, this reaction occurs in two steps. In the first step, the carbon bromine bonds undergoes heterolytic bond fission to produce a carbocation. In the second step, the carbocation gets attacked by a nucleophile. For example, it can be hydroxide ion or it can be cyanide ion, for example. The carbocation gets attacked by a nucleophile and it produces a tertiary alcohol. Now, this reaction is first order with respect to the concentration of the halogenoalkane. So, if I increase the concentration of the halogenoalkane, then the rate of this reaction increases. Why the rate of the reaction increases? Because if I increase the concentration of the halogenoalkane, then it produces more and more carbocation. And more carbocation means then the hydroxide ion can react more and more, and as a result, the product is also produced at a faster rate. And so this reaction is first order with respect to the halogenoalkane. If you can remember back to the previous slide, first order reaction means আমরা যদি concentration of the reactant increase করি, rate of reaction ও কিন্তু increase করবে, এবং এখানে আমরা যদি halogenalkane এর concentration increase করি, rate of reaction increase করবে, because increasing the concentration of halogenalkane means increasing the concentration of carbocation, and increasing the concentration of carbocation means increasing the concentration or making the tertiary alcohol faster. So this reaction is first order with respect to the halogenalkane. But this reaction is zero order with respect to the hydroxide ion. এই রিঅ্যাকশনে আমি যদি হাইড্রোক্সাইড আয়নের কনসেন্ট্রেশন ইনক্রিজ করি অথবা ডিক্রিজ করি, there is no change in the rate of the reaction. Why there will be no change in the rate of reaction? Because the second step depends on the product of the first step. Only after the first step happens, the second step can happen. So the second step is dependent on the first step. আমার second stepটা যদি slowly হয়, তোমার overall productও কিন্তু slowly produced হবে. The fact যে hydroxide ion can react very fast does not matter. The rate of reaction is limited by the amount of carbocation that can be produced in the first step. So আমি যদি hydroxide ion এর concentration increase করি, rate of reaction does not increase. আমি যদি hydroxide ion এর concentration decrease করি, rate of reaction does not decrease. And so this reaction is said to be first order with respect to the halogenalkane. This reaction is said to be zero order with respect to the carbocation. And so first order with respect to the halogenalkane and zero order with respect to the hydroxide ion. And if I add them together, I get 1. And this is why this mechanism is called Sn1 mechanism. Here S stands for substitution, N stands for nucleophilic, and 1 stands for it is mechanism of first order. So this is nucleophilic substitution of first order that occurs when I heat a tertiary halogenalkane with hydroxide ion. Now, this is not the case whenever I am heating a primary halogenalkane. আমরা যখন একটা প্রাইমারি হ্যালোজেনঅ্যালকিনকে সোডিয়াম হাইড্রোক্সাইড অথবা পটাশিয়াম হাইড্রোক্সাইডের সাথে হিট করব, it also produces a primary alcohol and it also produces a primary alcohol. Now, the reaction seems to be exactly the same, and the mechanism as a result also may seem to be exactly the same. But whenever we are actually doing experiment, then we see that the reaction is first order with respect to the halogenalkane, and the reaction is also first order with respect to the hydroxide ions. That means আমরা যখন এক্সপেরিমেন্টটা আসলেও প্র্যাকটিক্যালি করি এবং হ্যালোজেনাল অ্যালকেনের কনসেন্ট্রেশন যদি ইনক্রিজ করি, রেট অফ রিঅ্যাকশন ইনক্রিজ করবে। আবার আমরা যদি হাইড্রোক্সাইড আয়নের কনসেন্ট্রেশন ইনক্রিজ করি, তখনও রেট অফ রিঅ্যাকশন ইনক্রিজ করবে। দ্যাট মিন্স the mechanism must be different from the previous one. So this is my primary halogenalkane. And in this compound, the carbon-bromine bond is once again polar for the same reason. Bromine is more electronegative than carbon, and as a result, it tries to pull electrons towards the bromine itself, and so the bromine end is slightly polar. But this carbon-bromine bond cannot undergo heterolytic bond fission because the inductive effect from only one alkyl group is not enough to actually reduce the positive charge of the carbon. আমরা একটু আগে দেখেছি যে in case of a tertiary halogenalkane, 3 carbon atoms were providing electrons to the central atom, central carbon, reducing its charge significantly. But এখানে শুধুমাত্র একটা মিথাইল গ্রুপ ইলেকট্রন ডোনেট করছে, সো এই চার্জটা কিন্তু সিগনিফিকেন্টলি রিডিউস করে না, এবং এই চার্জটা যেহেতু সিগনিফিকেন্টলি রিডিউস করে না, this bond does not undergo heterolytic bond fission. But that does not mean the carbon is not positive. The carbon is still positive, and as a result, any nucleophile, for example, once again, our hydroxide ion or the cyanide ion, can attack this carbon. Understand? Look at the direction from it is attacking. It always attacks from the side away from the bromine, because the hydroxide ion and the bromine is, both of them are negative, so they repel each other. So it would attack from the other side, not from the bromine side. Anyways, this carbon is still positive, and this carbon, as this carbon is still positive, it is a site of attack by the hydroxide ion, and this hydroxide ion attacks this carbon, and the molecule enters into a transition state in which for a fraction of a second the carbon has 5 bonds, and here the carbon hydroxide bond is becoming stronger and the carbon bromine bond is becoming weaker. Because hydroxide is a stronger nucleophile than the bromine, when it attacks the carbon, it allows the bromine to actually to go away with the electrons from the carbon bromine bond. And after the transition state ends, we are left with a primary alcohol. And this mechanism is called nucleophilic substitution of second order. This is called second order because if I increase the concentration of the halogenalkane, the rate of reaction increases. If I increase the concentration of the hydroxide ion, the rate of reaction also increases. Because the reaction is happening by collision, if I increase the concentration of the halogenalkane, the rate of reaction increases. If I increase the concentration of the hydroxide, the rate of reaction also increases. So the overall order of the reaction is 2. And that is why this is said to be nucleophilic substitution of second order.